Hey there, everyone. Wow. First of all, thank you for choosing me over food. That's amazing. I'm so proud of you. You made the right choice. I'm extremely happy to be on the stage today, especially with you. And I'm even more happy because I'm going to talk about one of my favorite topics ever. We're going to talk about how to actually build your first MLOps pipeline. And official title goes how to actually enjoy it. But we all know that it basically means how to not cry yourself to sleep each time that you start to do something with MLOps. So let's dig in, because today we have a lot of talks to do. So basically, a little bit about me, because I'm sure that you don't know me yet. So my name is Kateryna. I actually have a lot of commerce background. I also did some work for platform teams, for consulting. And the first thing about me that you should know is that I'm totally in love with Google Cloud. So all examples today will be in Google Cloud, but we are doing Kubernetes, boys and girls. So if you want, you can switch to other vendor whenever you prefer and whenever you like. Also, I'm doing a lot of LLP pipelines lately. And basically that means that I run into the problem that nobody actually talks about how to get into MLOps and how to do it easily. So let's begin and let's check out how we can do it. First of all, if you are noticing me going into the Eminem mode, that's all right, because we have a lot of stuff to actually accomplish today. But still, I want to know you a bit better. So please raise your hand if you consider yourself DevOps. Amazing, nice. Please raise your hand if you consider yourself ML engineer. Okay, nice, good. And who actually are like once at least try to run some ML stuff on your machine, just for fun? Okay, amazing. Now there are more hands. And who knows what a Ray is? Who knows what Ray is? Okay, one person, second person, amazing. That's a perfect audience, because now I can talk about it quite more and I will open a new world for you. So basically that's my favorite means that I show quite oftenly, because that basically shows the reality. Because this talk is based on my own pain, blood and tears, because there is no pain, it's no fun, obviously. So the case was that we had amazing ML models. It was just gorgeous and everyone loved it. But when we started to do MLOps, we find out that the threshold is quite high and nobody actually tell you how to do it properly and how to make your MLOps production ready. That's a huge issue and a huge change to do. So let's dig in and let's check what we know about MLOps. First thing first, we know about MLOps quite a lot. First thing we know that MLOps is complex. Everyone talks about that. Everyone talks like, hey, MLOps, it's really tough. It's a tough domain. You need a lot of knowledge to actually get into it. Second thing we know about MLOps, and now DevOps will laugh a little bit, that MLOps, it's kind of DevOps, but not quite. And actually that's fun, because we are still arguing what is DevOps in the first place. And now we need to talk about what is MLOps in the end, so it's also tough. And the third thing is that we know that our MLOps should look somehow like this. Please don't get scared that the image is too small. Basically, I have a bigger one. So that's a good example of how Google thinks the typical MLOps pipeline should look like. If it works for Google, maybe it also works for us actually as well. So what we have here, we have some source code, obviously. We have some ML pipeline to run. Then we have some CI. We obviously have some CD. But then you can see some additional steps here. So we have data integration. We also need to evaluate our data, we need to evaluate our model, and we also need to think about magical ML metadata storage. What it is, hell do I know. Let's find out it right now. But please don't get scared with this image, because I have a simpler one from Databricks. It's actually oriented more on ML engineers. So let's dig into what actually MLOps is. First thing you need to know about MLOps, we have IDA. IDA is explanatory data analysis, where we can actually talk about data. So we structure data, we gather data, we make our data usable. Then we have a training and tuning process. So basically we are train and tune our model continuously, so it will actually give us good results. Also, we have a governance and review, and we know it from our commerce stuff, because we also do governance and review for the commerce applications. But in this case, you need to monitor for your model to be actually usable and that your model gives you good results in the end. And last but not least, you need to do a monitoring. But besides actual monitoring, like my model is alive and somewhere in the cloud, we also need to think about is my model not giving me a bullshit in the end? So we need to think about that as well. If you restructure it a bit differently, so one more image, let's dig into what we know about MLOps. So in theory, we kind of understand what the CI/CD is. We know this part. We all do it. We know it from commerce. Monitoring, well, we also know about monitoring. We know how to do it and how to dig into it. Then we have a new parts. We have IDA and we have CT. So CT is continuous training. That's when we're making our model train and train again. Let's find out about the challenges inside of these parts. Basically, when we talk about data, the first thing that you think about AI and ML, there was a lot of data for it. So huge amounts of data. Even more, you cannot just take random Kaggle data sets and hope that everything will be fine. No, nobody does like that. You need to prepare good ETL pipeline. So your model should be trained on really good quality data. Otherwise, it will give you bullshit in the end. So that's the first thing to do. Second thing that you need to think about, well, you have a lot of data. How do you plan to feed it inside of your continuous training pipeline? So it's a lot of money because you need to load your data from the actual memory to memory of your training pipeline. And that will cost you hell a lot. So that's the second thing that you actually need to think about. And the last and not least, you actually need to think about doing the continuous training. And that's another place to start because here we need to, first of all, think about that we need to a lot of resources actually under our belt to be able to process a lot of data, and actually we also need to get rid of them as fast as possible because nobody wants to pay extra for resources that are just doing blank thing. So for continuous training, the main challenge is to not only load the data, but also get rid of your resources in the cloud as fast as possible. And the dark horse of this slide is monitoring. Oh, here we have a huge surprise. Because everyone who actually deals with commerce systems goes so confident about monitoring. I know how to do latency. I know how to do performance. Well, that's good for you, and it's complex topics, but it's on the over the waters for ML. Under the water, however, we also have such stuff as data drift, concept drift, we have a data quality, and all of the stuff is just punching you in the face. So monitoring is stuff in context of ML. Basically, data drift, it's when your data is changing and your model is not retrained for it. This we can solve, but the concept drift is more difficult thing, that the patterns, they are changing and you need to adapt to it as quick as possible. So if you allow me, today we won't talk about monitoring anymore. We're going to talk about continuous training in details. But if you're talking about some doors that still should be opened, we need to open the door about the monitoring and model versioning. So model versioning is also a bit different from how we usually see our commercial software, because here we need to release new version when we're using new data. So new data produce new version of your model. New parameters that you feed in for the training also produce a new version of the model, and you need to track it. So you need to save some metadata with your model as well, so later you can go back and check when your model was performing the best. Example of the metadata could be performance metrics, some weights, also some pipelines that you used lately for data processing. You need to have some ID to actually save it properly. And why I'm telling you this? Because then you will need to do something like model registry. So that's basically like Git versioning for our awesome models. Basically, that's a place where you can store your model with some ID and some metadata, so you can get back and reiterate when your model performs the best. I think DevOps now like sit there and listen and think about like, this sounds kind of familiar. So basically, you can treat your model registry like a Docker hub, because there we also have IDs, we also have labels, we also have some tags that we can use, and also some rollbacks that we can reiterate. So basically, if you want to go hardcore and actually implement model registry right, you should use something like MLflow. That's an amazing tool where you have a dashboards, where you have a lot of tools. But if you want to go cheat sheet and you need to quick solution it, you can also do a Docker hub for the models that are stored as a Docker images. And I will show you in a second why and how. Also here we have amazing things. That's my favorite slide to explain for the stack. Here we have Kubernetes, Docker Hub, and Ray. And let's dig into it, why I suggest you such a complex thing. So next thing you should know, the first and nice thing to do is to create technical tasks. So what we plan to do, we plan to integrate actual huge CT pipeline with some trigger. For example, like our data came into the storage, we need to load it from database, and then we need to do model training. After that, we'll publish something to the model registry, and in the end, you will have our application running in CERT. And here's this why I actually recommend you to use Kubernetes for the 4 reasons. First reasons we know very well. So we know that write once, run everywhere. That's the best thing that you can tell about Kubernetes. We will avoid vendor lock here. Next thing, Kubernetes solves our problem for continuous training. So when you need to get rid of your resources as fast as possible, Kubernetes is waiting for you. That's exactly the place where you can get rid of the resources that you are not using quite quickly. Next thing, Kubernetes has amazing ecosystem. So you are choosing tools, tools no longer choose you. And the last but not least, and you can argue with me about that, but we know what to do with containers. So containers is known space, is safe place to start. If you don't know anything about MLOps, you probably know something about containers. So you at least once saw the good example of it. Next thing is Ray, and finally we are here. So that's my favorite tool actually in ML context right now. I talk about it a lot. I hope they will pay for me one day. And basically what the Ray is, it's open source tool that allow you to manage low-level processes with a high-level Python API. Just listen, let to sink in. So basically, what Ray does, it takes away all the responsibility from ML engineer for the distributed processing and handles it on the level of Ray core. So all the distributed processing is taken away from you. The next thing, Ray also is good because it doesn't require you to implement all the libraries that it has. We have also a set of libraries for basically all stages of the life cycle inside of our Ray, for data, for train, for tune, and we can get into this in a minute. And also, I usually tell people that Ray is extremely easy for the engineers, and I will show you why. Because easy could be questionable word. So basically, why we need to care about the distributed processing? Distributed processing is the thing that comes into play when you cannot just fit your training pipeline on the one machine. So you need to split your training and your load between 2 GPUs. And trust me, no one wants to do it by hand, nobody. Because you need to care about memory operations, CUDA operations as well, and you need to think about all this stuff. And Ray is exactly the place where you can solve it. So let's see some code. If there is any Python engineers, just enjoy it. Because basically what Ray does, it creates a wrapper around your code, and you don't need to change your code at all. At all. No changes need to be done, except of adding the annotations. And after that, the framework will do the job for you. So it creates a box around your program that will be used for doing the distributed processing. So here we have example with a nums of CPUs and GPUs, and that's how Ray can control how much of CPU and GPU your process using. Next thing that we're going to talk about is the Ray data. It's amazing thing as well, because here we can load our data in batches. I have amazing example here about how Pinterest integrates the Ray into their pipelines. I recommend it to choose. So Ray allows you to not load anything to your memory, but stream it. So it's extremely cheap for you. You are not loading your information 2 times. You are doing it only once, and that's how your workflows will be much, much more cheaper. The next thing here is the Ray train. It allows you to choose the worker. So basically, you can choose a Hugging Face, PyTorch, any other framework to train your model, and it will handle the distributed processing under the hood for your training models. And last but not least, we also have a Ray serve. Here we as well have only one annotation to make your actual model available in the cloud after all of that. But I keep talking about Ray and Kubernetes and how it will manage it all. Well, it feels there is a missing piece. So we have some problem here to actually manage it. In the end, we have a KubeRay. KubeRay is an amazing tool. It allows us to communicate our Ray model needs to our Kubernetes. So basically, all the monitoring will be used with actual Kubernetes operations and 3 resources. Simplicity is the key here because we have Ray cluster, that's the box where we can put our model. Second thing, we have a Ray service where we can put our actual serving. And last but not least, we have a Ray job. Ray job is gorgeous thing because imagine you are doing training, you need to clean up your resources. Normally, you create some cluster, some Kubernetes configuration. Here, Ray will take care for it. So Ray will clean up resources in the cloud itself when the model will be done. It's quite good and quite nice already. And next thing is actually chill out slide, because we are quite quick already. I'm making sure that you are not asleep. So just remember about technical tasks that we had in hand. So here we needed to create the continuous training pipeline. We're doing some data loading, we're doing some model registry, and we're doing some application serving. That's the solution. Basically, what you need to do, first of all, you need to create a scheduler where you will do some once-in-a-time training pipeline. After that, you will need to produce the event to pops up. In the end, you will have a cloud function that will trigger the Ray job inside of the container, and we will scale on the autoscaler with Google Cloud. And in the end, you can publish it into the ML flow or into the Docker Hub, depending on what you want to do. And here, you may actually question it a lot. You would like, Kateryna, you said that we won't cry actually during this all stuff. It already looks complicated to me as well. But the thing is that even if you will go with some easy solution like WAWTech CI, you will still need to do the infrastructure. So if you want to automate something, unfortunately, you will always run into the same issue. So that's an example architecture from Google Cloud, how they recommend to do your WAWTech pipeline. So basically, unfortunately, you cannot run away from it. Also, the problem here is that I'm a bus killer and I counted everything. So you can see the example. On the right side, you have the example with WAWTech CI. And on the left side, you can see the amount of money I spent with the GKA training. And basically, it's 5 times cheaper. So if you are going with the cluster approach with the GKE, you are economizing yourself 5 times more money. And last but not least, why you should use this approach is that actually, WAWTech CI uses GKE under the hood. So if you want it or not, you are using Kubernetes under your own will. So that's basically official documentation that you can find in the Google Cloud as well. But also I want to show you this slide, because here you should scan it, because this exactly shows full run book of the solutions that I showed today. Because of course it was quick, unfortunately architecture was quite complex, so I recommend you to read it a bit more and actually play around at home how to do it best. So here you can find the full guide with all resources, all videos that I used, and I hope this actually will save you crying time a little bit. And scanning, please, scanning. So nice. I think the video also will be available, so you can find it as well. And also, if you want to connect with me, I highly recommend you so, because usually I'm quite friendly. I also have a Ukrainian blog, if you would like, because I write some articles about the ML. Also, I plan to dig into the monitoring a bit more, so you will see more examples of it. And I can move maybe, I don't know. Hopefully you see it well. Actually, I will also be here for the Q&A, and I can show you diagrams about architecture a bit more and in depth, because we had a limited time. And actually, I don't see our organizers, so maybe while they are not kicking me out, we can look into the diagrams a bit more. Huh? Good. So basically, let's look into diagram a bit more, because I seem to have a little bit of time. So what we have also here cloud functions, and each DevOps probably already feel that it's a bit of redundancy here, because in theory, you can do just pops up and do the querying based on the events that come into pops up, and it will be enough already. Why I add this part as well? Because in future, when you will do some fancy model evaluation, for example, with Evidently AI, so you will do some fancy monitoring, here would be perfect place to integrate it. So basically, on this step, exactly, you can actually integrate your Evidently AI or any other tools that will actually calculate that your model is acting good and fine and nicely. And exactly on this place, you can actually manage the monitoring as well. So basically, in Google Cloud and in other providers, you can create the events based on your metrics. And if your metric go down, you can create a pub sub event or any other event if you prefer in other provider. And in this case, you will retrigger your model training automatically based on the metrics. And that's exactly what you want to do. Because you don't want to train your model like 5 times a day. You want to do it only once, preferably in a week, with new releases, with new data. For my customers, the best approach that they took was when the data changed and the data was loaded into the database. They were doing this part where they triggered events to actually do the retraining based on the new data that they provided. So that would be a minimum architecture to integrate your MLOps pipeline around. Hope you will be happy with it, and hope the runbook will help you a lot with training this model. And I will show the runbook again, so everyone who haven't had a chance to scan it can do it as well. Perfect, I think everyone did it. And also, in addition, I think that to finalize all the stuff, I can show the slide again. Yeah, thank you, everyone. It was amazing to be here with you. Thank you.